Happy Labor Day to all of my fellow Americans out there. Welcome to another installment of LeetCode Live, where we do daily LeetCode live streams, pushing the boundaries of our comfort zones and trying to hit our marks as we get closer and closer to our goals. So if this is your first time here, what exactly is this stream? I'm going to try to keep this short so we can get to the content right away. About a month ago, on July 16th to be exact, I went on a journey. I started a journey of trying to do every single LeetCode question on the platform. And I decided that I wanted to stream myself doing it, not just for my own practice, but to hopefully give viewers a different perspective on approaching LeetCode. My streams are not intended to be a place where you can learn how to LeetCode, but I do hope that if you are watching my streams, you might be able to hear how I approach a problem. You'll hear me struggle, and sometimes you'll even see me skip a question because I don't understand it. And I just want to make it so that people can relate to me, right? A lot of times we see people that they're geniuses and they're perfect at LeetCode, and a lot of people get discouraged by that. So I want to give a different perspective into someone that is on the grind themselves and is struggling and trying to get better every single day. And that's what I think most of us are doing. And if not, that's what you should be doing. It's good to do that. It's good to go through that struggle. So that's what I hope this stream can provide. So I started on, question 0 as an easy one. I sorted by acceptance, and I've been trying to do every single question on the platform. I'm not even going to get to any mediums until we get there. The only reason we have 2 mediums done right here are because some of the easies that we've done have since transferred over to medium style questions. So I think that's pretty neat. I mean, it means that I guess we got lucky, and you can give yourself a pat on the back because some of these have become mediums since then. So we are on 235 questions right now, and without further ado, let's just go ahead and get started. So we're currently on page 3 of LeetCode. Let me go ahead and go to that page. And the last question that we want to get to, or the question that we need to get to today, is longest uncommon subsequence, which has, I could only imagine, the worst like to dislike ratio that I've ever seen on a question so far. Because of that, I don't want to spend so much time on a question that's not of high value. So I'm going to just skip that question. We can get to that on another day. Let's get to something like this, which looks a little bit better. Okay. So you're given an array nums of non-negative integers. Nums is considered special if there exists a number x such that there are exactly x numbers in nums that are greater than or equal to x. Notice that x does not have to be an element in nums. Return x if the array is special, otherwise return -1. It can be proven that nums is special. The value for x is unique. I feel like we tried to do that one yesterday during our weekly roundup, but let's just go into it today. By the way, I'm probably going to keep this stream a little bit shorter. I know I said that yesterday and I still went over the hour. I want to keep it short because it's Labor Day and I have things to do with my family today. So, and I hope all of you are also going to be spending time with your loved ones and family, but let's get right into it. So there are 2 values, 3 and 5, that are greater than or equal to 2. Okay. No numbers fit the criteria. 0, 4, 3, 0, 4. There are 3 values that are greater than or equal to 3. Okay, if we went, let me see, 1, 2, 0, 1, 2, and then 3. There are 3 values that are greater than or equal to 3. How could we? I mean, it can never be more than the length of the array, right? Like let's say I had an array that looked like this. You know what I'm thinking though? You know what I'm thinking about doing? If nums.length is of length 100, now we're gonna have, I don't think it really matters. Does it matter the frequency of each one of these? Yeah, I guess it does. 3 values that are greater than or equal to number 3. If I stuck all these in a frequency array, so I'm doing this. This is going to be a frequency array where each index represents the number. The value in each index represents the frequency of the ith number. So 0, there's 2 zeros. So we put 2 at ith, or I equals 0. We put 1, 2, 3, 1 and 3, and 2 and 4. And they want that there are 3 values that are greater than or equal to 3. So I think what we can do is, after I get this frequency array, I can start from the end and start counting the frequency. So by the time I get to 0, 1, 2, 3, I get to the third position, and at that moment there are 3 numbers that are equal to the index I'm currently at. And one of the reasons I feel like I can create one of these arrays, like a statically sized array, just from the get-go, is because we're given this upper bound right here, which is a nice number. It's 1,000. That almost leads me to believe that creating an array of that size would be the way to go. Let me, as I always do, check my stream. Okay, sounding good. Am I too loud? Way to go. Maybe not, maybe not. I think we're good, we're good. So I'm gonna go ahead and get started with that. So what we're gonna do, we're gonna create a new array. We're gonna call this frequency. New array, we'll fill this up with nums.length, or actually no, not nums.length. We're gonna do 1001 because we wanna store numbers from 0 to 1,000. Okay, now what we can do is for const n of nums, make sure to also fill this up with 0. We can say frequency of n plus or equals 1. Right, so right after this, what have we done? We have an array of size 1001. We filled it up with all zeros. And then we went through every single number in nums, and we incremented at that index. We incremented the value by 1 to indicate its frequency. Now I think what we can do is we can say let frequency count equals 0. We'll start from the end of our frequency array. I greater than or equal to 0, I minus minus. Now what we can say is we count the frequency first. So frequency counts plus or equals frequency of I. If frequency count is equal to I, then we return I. Now, do they give us a value? Otherwise, return -1. I think this is the answer. Let's just go ahead and run it through our test cases and see what we get. I'm curious about 0 and 0. -1, -1, -1. Oh, I know why. One of the main things is we need to sort this. So let me see. Let's do const sorted nums. I guess that was the... Actually, does that matter? It shouldn't matter if I sort it or not. So perhaps I might be... I think there's something I did wrong here, obviously, right? Because 04304 inside of my frequency array, I'll have what? Frequency is new array for const n of nums, frequency at n plus or equals 1. So frequency at 0 is 1, 0, 1, 2, 3, 4. This is 1 for the 4, 1 for the 3, another 1 for the 0, and another 1 for the 4. Frequency count equals 0. Now we go from let I equals frequency dot length. This should be -1. I greater than or equal to 0, I minus minus. So frequency count plus or equals frequency of I. So frequency count here is 2, but it's not equal to 0, 1, 2, 3, 4, right? Then we go to the next one. Frequency count plus or equals frequency of I. That's 3, and 3 does equal I, so we return I. Now here, for the 0, this is the part that's going to be interesting, right? Because, well, actually no, I guess not, because we'll have a frequency array of 0. However, let me think about this. Even at the end, yeah, we'll never have one that equals, like we'll get to 2 at the bottom, but 2 is not equal to 0, so we don't return anything. Then we have 3 and 5. 3 and 5, if we have our frequency array here. We have 0, 1, 2, 3. So we have 1, 3, and we have, let's see, 1, 5. I'm getting this all messed up here. 0, that's 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. I went 1 over. So we have 1, 3, 0, 1, 2, 3, and we have 1, 5. See here, frequency count plus or equals if frequency count is equal to I, which is 2. Frequency count here will be equal to 2, so we return I. Okay, that might work. Now I don't know why didn't work before, but let's try this again. 2, -1, and 3. Okay, so looks like we got the right answer from our test cases. So let's go for it. Submit it. See, I like this question a lot. So yesterday, it's funny because yesterday in my stream, I'm gonna have a sip of coffee, by the way. A sip of coffee. That's what happens when you have coffee. I'm just like talking so fast right now. I'm not addicted to coffee, but I do have 1 cup of coffee every day, and I love it. And there's nothing better than that first cup. Maybe that does sound a little bit like of an addictive personality, but cheers to everyone out there having coffee too. This question's cool because yesterday I tried to do it, and to be honest, I was a little intimidated by it. I was also just towards the end of the stream, and maybe I wanted to do something else. You know, I was thinking about the other events I had. This whole weekend has been crazy. It's been full of family events. So during all these streams, I've been thinking about events I'm going to be doing later on in the day. So sometimes you just want to maybe go out and spend some time with family. Now, based on these percentages I'm getting, I am thinking that there is a faster way of doing this. I thought this was pretty quick because the space complexity here is constant, right? And our time complexity is n. I feel like those are pretty good numbers, but perhaps I am going through more than I need to. Maybe I don't even need new array 1001. Maybe I don't need to go all the way down. X does not have to be an element in nums. The value for X is unique. I feel like this is a good way to go about it. I'm very curious to see what discussions say. Is there like a one-line bitwise manipulation in clean Python O of sort? Concept is similar to h index. After a while loop, we can get I, which indicates there are already I items larger or equal to I. Meanwhile, if we find I equals nums I, there will be I plus 1 items larger or equal to I, which makes array not special. Time is O of sort. O sort, we can achieve O of n if we use counting sort. It can be faster by using binary search if the list is already sorted. See, I was thinking binary search can be good too. Essentially, I want to find an I such that nums of I minus 1 and nums I bracket of I, alternative implementation. This is the best answer. Basically, this problem is not easy level if we limit the time complexity in at least O of n log n. Nums of sort reverse true while I plus 1 if negative I. So O of sort, pizza 100, X plus 1 for int elements. Thanks for sharing and some explanation. O of n time, O of n space. Count number of occurrences for each number within 0 through nums.1.length, and log n, easy explanation. The number we are searching for is any number from 0 to length of array. If we sort the array in ascending order, we can iterate through it from left to right, checking if the number of elements until the end and the current value meet the condition of success. Those are the number of elements in the current index until the end is less than or equal to the current value. I think it's easier doing it the other way. From the back. I don't know, I'm looking at some of these and I feel like our solution is just looks more simple. But that's my take on it. I'm pretty happy with it. I would love to hear everyone else's thoughts. Let's keep going here. So count elements with strictly smaller and greater elements. Interesting. Given an integer array nums, return the number of elements that have both a strictly smaller and a strictly greater element appear in nums. So the element 7 has the element 2 strictly smaller than it, and the element 11 strictly greater than it. Okay, when I look at this question, let me see. How many numbers to the left are smaller, and how many numbers to the right are smaller? If the smallest one, Like two ways I'm thinking of doing this is, what if we had an array? What if we had like two arrays, one from left to right, another from right to left, that we kept track of the numbers that we've seen so far, and then we can iterate through our input array using those two new arrays that we created, and maybe that can help us. Give me a second. Gotta keep that phone charged, you know. All right, -3, 3, and 90. The element 3 has the element -3 strictly smaller than it, and the element 90 greater than it. Oh, so it wants us. Oh, okay, any number. So like 11 has something greater and something less. That's 1, something greater and something less. 2, something greater, not something less, not something greater, but something less. Okay, so it's just any one of these. If I were to sort this, I mean, we could sort this, right? And then I think really we just need to count. Oh wait, if we sort it, wouldn't it just be every, wait a second, are all the numbers unique? Nums.length. And the nums.length is less than 100. Because wouldn't it just be every number? Because yeah, if I sorted it, if it was 2, 7, 11, 15, it would just be every number that's not on the edges. Right now, there could be duplicates like we see here, right? This is -3, 3, 3, and 90, right? So we would have to go. So this is 2. Oh yeah, okay. So we would have to go here. This is different. Okay, so get to the first different number from this edge, and then the first different number from this edge. And then I guess it's 2, because this has this, and this has that, and this has this, and this has that. So I think we can get away with doing that. However, we'd have to sort it, which I'm not like a huge fan for sorting unless I absolutely have to. Is there another way that we can figure that out? Oh, is it just the min and the max? What if it was like, well, it's not the min and the max, because 3, well, if this was 3, 3, 3, this would have bigger but not smaller. Okay. The smallest is 3, the greatest is 90. That's O of n. If I found the minimum and I found the maximum, yeah, I can find the minimum and then I can find the maximum. Maybe let's try doing the sorting method, where I want to sort it and I just want to find the first non-unique number. Like if this was negative, or if this was 3, 3, 3, 4, I guess this would be 1. So this would be 4 is the first different one. 4 is the first different one. That's 4. If this was like, or 3, 4, 5, it would be here and here. So I guess that's just 2. Is it just however many elements, the distance between these two, including those? It could be that. It could be that. Let's try that out. Let's do const sorted. I'm gonna do this to make a copy. A minus B. So I want to find, let me see, const, and the length of this, it could be 1. Okay, const first, or let first equals 0, let last equals nums.length minus 1. Okay, so for let I equals to 1, I less than nums.length, I plus plus, if this should be, let's make this sorted, doesn't really matter, but just to keep things consistent. if sorted of I is not equal to sorted of I minus 1, then first equals I. Then I'm going to do the same thing here for last, but here we'll start at sorted.length minus 1 greater than or equal to 0, I minus minus. If sorted of I is not equal to sorted of I plus 1, then we'll do last equals I. And then can we just return the difference of last minus first? I wonder if this would work. Negative 3 and 2. It should not be negative. That's weird. Sorted of I not equal to sorted of I minus 1. First is equal to I. So if we have 2, 7, 11, and 15. So we start here. These are not equal, so first is 1. I equals sorted.length minus 1 here. I greater than or equal to 0. I minus minus. If sorted of I, oh no, this should be minus 2. Should start here. Although this is kind of weird because if we get an array of size 1, that thing's just not gonna work. Although I guess this condition wouldn't even start. If sorted.length is less than 2, this is 11. So then last equals I. Last minus first. That should be 2 minus 1, but that's 1, not the answer that we want. And we're getting negative 3. That is very interesting. So you guys understand what I'm trying to do? Like, I just want to find all the numbers inside the first ones that are non-unique. But there's probably, I think there's a better way of doing this. Anytime I think about sort, I don't know, like I just really don't like sorting. Even though I know sometimes that's the best that we can do, I just think sort and I'm like, no, there's gotta be a better way. And I don't know if that's like a good mindset to be in. I almost feel like I got myself into like a bad, let me see, return the number of elements that have both a strictly smaller and strictly greater element. It can't be any of the unique ones. Sorted nums.sort a minus b. Yeah, I mean, we just have to find the distance between the first two unique numbers. Negative 3, 3, 3, 90. Because again, in this case, I can't just return, well, yeah, because if this was negative 3 and then negative 3, it would still not work. Strictly smaller and strictly greater. I feel like I'm on the right path here. So for let I equals 1, I less than sorted.length I plus plus, if sorted of I is not equal to sorted of I minus 1, first equals I. So let me just, like, why is this becoming? First is 3? Am I missing something here? Oh, wow. Obviously. Classic mistakes. We need to break. Because then our loop is just going to keep going, right? Our loop's not going to stop. Our program is doing exactly what we told it to do. Now I get negative 1 and 2, but perhaps here, maybe we just want to count the distance. I mean, can we just include 1? Or is that, this also seems a little bit hacky. 2 and 2. We can try submitting it. Let's see. 1 expected 0. I'm very tempted to be like, oh, if it's just of size 1, I mean, because if it's length of 1, that's not great. I mean, we could say if it's just, if nums.length is equal to 0 or less than or equal to 1, return 0. Okay, yeah, I figured something like that was gonna happen. I know when I get to this point where I'm like just adding random edge cases like this, it's because I came up with the wrong, yeah, the wrong algorithm here. This is interesting though. This is strictly greater. Both a strictly smaller and a strictly greater element appear in nums. Oh no, that's, oh, expected is 0. Yeah, okay. Oh, and you know what? You know what? Maybe it was wrong because this should be, if sorted I is not equal to sorted, this should be 0. We want the first thing that's not equal to 0, and this should be the first thing that's not equal to sorted.length minus 1. Right, now if I enter this, let's go ahead and put our previous test cases. I think before, what we had 1, let's try these. Let's try all these. 2, 2, 1, 1, 100, 2, 2, 0, 0. Is it because of this? Oh no, but then that's also going to give me, we still have 100, huh? Sorted I is not equal. Oh, but then that just also, yeah. What if we just got the count of every number not equal to, no, again, it can't be 0 because well, actually, I wonder if we can do that. Can we just get the count of every number that's not equal to the outer bounds? Is that also something else that we can do? Let me try that out. Instead of doing this, what if we did return sorted dot reduce accumulator and value? I think here we get the index and the original array. So if value is not equal to array at 0 and value not equal to array at array.length minus 1, return accumulator plus 1, else return accumulator plus 0. Could we also just check the bounds? Okay, now we're all over the place. 2, 2, 0, 0, 0, 1, 1, we got 4. Oh, but only if index. Yeah, it should be if val is not equal to, let's do this, and index not equal to 0 and index not equal to array.length minus 1 and yep, caught ourselves in a hole. Because also what I was trying to do is like for every element that's not equal to its extremes in this sorted array, like if it's not equal to 2 and it's not equal to 15, I can count it. Yo, what's up, Marvin? So if index is not equal to 0 and index is not equal to r.length minus 1 and val is not equal to array at 0 and val is not equal to array at array.length minus 1, return accumulator plus 1. Yeah, happy Labor Day to you too, man. Thanks for joining. Oh, and I also realize here that we need to be returning -1 for some of these, and we're not. 0, 0, 0. We got 0 for the last one, 0 for the last one. We got 1 for this one, which I'm not even sure why. Because if index is not equal to 0, which it is here, huh. Let me see if we can do one more. I'm probably just going to skip this one to get to something good. Let me see. I think I've done this one before. Capitalize the title. Given a string title consisting of one or more words separated by a single space, where each word consists of English letters. Capitalize a string by changing the capitalization of each word, such that if the length of the word is 1 or 2 letters, change all letters to lowercase. Otherwise, change the first letter to uppercase and the remaining letters to lowercase. So first letter of each word. Okay. If the length of the word is 1 or 2 characters, change all letters to lowercase. Otherwise, change the first letter to uppercase and the remaining letters to lowercase. I feel like this is just like, we can just go through this. We can implement 2 functions that do this. Actually, we don't even need this. We can just check the length of the string and then do a to lowercase on it. Else, yeah, otherwise change the first letter to uppercase and the remaining letters to lowercase. It seems pretty algorithmic in nature. Let's see what we can do. I think we can just return the capitalized title. So let's say here const capitalized title. We'll make this a new array. And then for here, I can say const split title equals title.split at the space for const word of split title. If word.length is less than or equal to 2, then we can do capitalized title dot push word to lowercase. We can do that. Else, all we need to do is, let's say, we can say happy Labor Day and happy Teacher Day. Taking my shot at UKG and American Express. Laugh out loud. Hopefully I get an interview. Nice, man. Good luck. Rooting for you, man. That's awesome. Please let me know about your progress. So in this one right here, I mean, a couple ways that we can do it. We can, yeah, I mean, we can just like slice things. If I slice a word, that's just going to give me a copy of that one. How do I want to do this? Let's see. I can say const or let new word equal. Let me see. We can say word of 0 to uppercase. And then for let I equals 1, I less than word dot length, I plus plus. New word plus or equals word of I to lowercase, and then capitalized title dot push new word. And then at the end, can we just do return, what is it? Capitalized title dot join. We do this. Capitalize the title, capitalize the title. I think there's probably a more effective way of doing this, but I think it's pretty straightforward. 71.0. Wow, literally the same thing, 71.10. Sweet. Awesome. So I think I'm going to wrap it up here. Again, I wanted to keep this stream short since it's Labor Day. I know a lot of you probably are going to be spending time with family or taking the day off. So I just wanted to make it so that if you're watching this stream, it's just a short one for today. We'll resume tomorrow with our normal 1 hour stream. So don't worry, on the weekdays, I'll be doing my normal 1 hour, but it's a special day today. So I hope all of you have a great rest of your Labor Day. Take it easy. We'll get back on the grind tomorrow. Have fun today. Spend time with family. Go outside, make some burgers, drink some beer, have a great time. Until next time, we'll see each other tomorrow. Hope you have a great rest of your day. Happy coding, everyone.